BJT. Bipolar junction, the transistor. Okay. Right. So today we have the few more the questions. So I'm gonna the drawing. I think you can see that, right? That was BJT here. Okay, that was RC. Okay. And that was for like this one here. That was register for the base. And that one is for the DC voltage. With a BB.
Yeah.
2 volt. And that was 100K. Yes, sir.
I'll talk to you.
Oh, yeah. All right. That RC is 1 kilo ohm here. And V sub CC and 100 volt. And then that was the NPN, the transistor. Okay. NPN transistor. I think I'm gonna give you more. Is the better for you. Okay. All right. And the beta gain, we assume that 200. Okay. So do you remember it's like the we have maybe the two type of the BJT. The one is the NPN, the other one is like PNP. But now for this semester, we're gonna analog for us only usually consider about the NPN transistor. So you have still confusing, go to the starting point of the printout for the chapter 5. Okay. So now I assume you have already the basic concept and definitions we go through. Very important. Why do I have to say very important? Just only one reason, okay? Quiz or lab or second exam. Very similar question. All right. So that is the circuit, okay? And then do you remember that point is the base? That point measured for E, the emitter, that is for the point of the collector. Base, emitter, collector. Due to the NPN, the BJT, the arrow from the base to the emitter here. So I think you can see from the printout here, the questions, several questions. What is the I sub B? And what is for V sub RB? V sub RB means like this one, V sub RB. But this point, the question is that they assume that second approximation. Second approximation mean real case, okay? Real case. All right. So what is the I sub B? What is the V sub RB? Okay. Step 1, okay? Step 1, that is almost the solution for the exam. You have to really keep in mind. So the I sub B here, V sub BE for this, the second approximations, V sub BE is what? 0.7 volt. But the first maybe approximation, not second approximation, for the first approximations for the ideal cases, it's going to 0. Okay, it depends on the question. So right there, to find the I sub B, you have to find, okay. So let's say V sub R sub B, that one here, V sub BB minus the V sub BE. Okay. So V sub BB minus the V sub BE. Why? Because that looks like circuit, the closing loop circuit. Voltage. This is my diode. This is SI diode. You remember? So right there, the V sub BB, the 2 volt minus. So V sub BE is what? 0.7 volt. So right there, 0.7 volts, like 1.3 volt. Okay, 1.3 volt. And then to find the I sub B, the I sub B is like this one. It's kind of the total current from the AC circuit. So the I sub B is V sub BB minus V sub BE divided resistor. Okay, like this one. V sub BB minus V sub BE divided R sub B. So that one is R sub B, 100 kilo ohm here. The V sub BB minus V sub BE right there, 1.3 volt. Okay. So I'm gonna using the calculator divided 100 here. 13 micro amp. Very small, very small. Why? Because we learned before I sub E, like this one here. This is I sub C. So I sub E is equal to I sub C plus maybe I sub B. Okay. So one more time, I sub E is equal to I sub C plus I sub B. But the I sub B is very, very teeny, the smaller one. So usually that was I sub C.
So I sub B is the same as current.
Yep. I mean, for this case,
yeah,
for this circuit, there's a lot of application, much changing the a lot of type of the BJT circuit. But for this case, yes, you're right. Okay, any question? And then the third one, we can see that. Do you remember the I sub C? Sorry, the I sub C is equal to beta times I sub B. The beta was given right there. And the I sub B, we have already calculated. So 200 multiply I sub B, 13 micro amp here. So 2600 micro amp, 2.6 milliamp. Okay, it's right there. Here. So the finally answer is the 2.6 milliamp. Okay, why? Because micro, the 10 to minus 6, milli, 10 to minus 3. Okay. Right. Any question? Okay. So next one. Next questions. I'm gonna give you the 5 minutes, but I'm gonna drawing first. Like this one. Okay. Here. That is the collector register. This is V sub CC, the temple. That is my ground here. Okay. And that was register R sub B, the register for the base part. And like this one, this is the V sub BB. Okay. All right. So that is 1 mega ohm here. And V sub BB is also same 10 volt. And R sub C is 2 kilo ohm here. Okay, plus minus. Okay. All right. So that was Junction second approximations, or means weird case. Okay. So we are looking for what is the base current and what is for I sub C, the collector current, and what is V sub CE, the voltage of the collector and emitter side. So because that is a C, that is B, that is E. So V sub CE, like this one here. Okay. So that was the one of the questions. Number 4 is what is the collector power dissipation? So that is the T sub D. Okay. So the step by step. The question 1, what is the I sub B? The I sub B is V sub BB minus V sub BE right there. V sub BB minus V sub BE divided what? The register, the R sub B. Okay. The V sub BB, the 10 volt, minus V sub BE here, minus 0.7 volt. Okay. And then R sub B is 1 mega ohm here. So after I calculated 9.3 divided 9.3 divided 6. 9.6 microamp. Okay. Any questions? Okay. So the second question, just right there. What is the I sub C? Oh, I'm gonna missing for the beta. I'm sorry about that. The beta is 300. We assume that. Okay. So the I sub C, the beta times the I sub B. The beta 300 multiply the I sub B right there. Here. Right there. 9.6 microamp. Okay. So maybe after calculated 0.6 multiply 10 to minus 6. There we go. So 2.88 milliamp. Don't confusing about the union. Okay. When you quiz or the exam. All right. Any questions so far? All right, good. And then the question 3 here. What is the V sub CE? So you can see that that is the 2 supply voltage. The one is the V sub BB. The other one is V sub CC. There is the 2 circuit. There's a 2H circuit. Okay, that one. So the V sub CE is V sub CC minus V sub RC, right there. V sub CC minus V sub RC is equal to V sub CE. V sub CC minus ICRC. Okay. V sub CC minus I sub C times R sub C. So V sub CC is what? The 10, right? Maybe Eden. And minus I sub C RC, 2.88, that's right there, 88 milliamp, multiply the RC, the 2 k ohm, 2 k ohm here, right there. Why? Because the R sub C like this one, and with I sub C, we have calculated beta times I sub B, 2.88 milliamp. Okay. So 10 minus 2.88 we multiply 2 times 4.2 voltage here. Okay. Maybe I'm gonna skip the calculation, just like K0. Right? So we are calculated I sub B, step 1, find I sub C, and finally we find the V sub CE. The last one is kind of a new concept, but what is the collector power, what dissipations means? What is the power at the point the collector V sub C here, right? So the P sub D is V sub C sub E multiply I sub C. That is solutions. So V sub CE is what? 4.24. Why? Because we have already calculated the V sub CE, just right there. Okay. So V sub CE 4.24 multiply I sub C. I sub C is like this one. We have also calculated from question 2. Multiply 2.88 milliamp. Okay. So after we calculated 24, multiply 2.88. Okay. 12 milliwatts. So 12 milliwatts. Okay. 12 milliwatt. Why? Because this may be active power. The unit is the watts. Milliwatt. Okay. Milliwatt. All right. Any question? I know a little bit boring, but we have to do. Okay. Next one.
Are you talking about me? Yes, they forgot to tell us that he was rich. I'm not rich.
Come on, Alice.
It's not a mansion. It's a 2-story house.
What kind of story house? What does that mean, sir?
It's a 2-story that the stairs. It's really open.
Usually the second floor in the housing, right? In the United States. So usually second floor, right?
Definitely a good chunk of like 2-story houses. Most of the bedrooms are upstairs. The downstairs is like a kitchen, living area.
Okay.
Yeah, like a den.
Awesome. Awesome. All right. Okay. All right. All right. Awesome. All right. So next one, example 3. A little bit boring, but we'll try to do. So like this one here. Okay, that is also V sub CC, like this one. Here we go. This is maybe a register for the base. This is the base power supply voltage, 15 volt. And that is for 470 k ohm here. And definitely there's the maybe NPN, the transistor. This is R sub C is 3.6, that 3.6 k ohm here. And V sub CC is 15 volt. Okay. But for this case, the ideal transistor, okay, and the beta is 100. Okay, 5 minutes. Okay, but keep in mind the ideal transistor means this is C point collector, base, the emitter. The ideal transistor means V sub BE is going to the 0. Right? So the question is the same thing. What is the I sub B? What is the I sub C? What is for V sub CE? And what is for I sub E? Okay. Right. That is the question 3.
I mean, I'm a little snippy too.
All right. So the question 1, what is the I sub B? I sub B, usually V sub BB is right there, minus V sub BE right there, and divided the register R sub B. So the V sub BB, 15 volt, minus, okay, minus V sub BE, 0. Why? Because the idea, yes, right, maybe Eden. This is the ideal transistor, so this is Y, and R sub B is what? 470 the k ohm. So now 15 divided 470, okay, 31.9, approximately 32 microamp. So really small. Okay. Any question? All right. Perfect. And then the second one is, what is maybe I sub C? I sub C, the beta times the I sub B. The beta is also the given right there, 100. So 100 times the I sub B, just right there, 32 microamp. Okay. So 320 milliamp. Okay. Right. And then the third one is V sub CE. The V sub CE, go back to the circuit. That is for V sub CE, right? That is for V sub CE. Okay. So V sub CE is for V sub CC minus the I sub C times R sub C. Okay. V sub CC minus I sub C times R sub C. Okay. So V sub CC from the circuit, 15 volt. minus the I sub C. We have already calculated before. 320 milliamp multiply the R sub C. 3.6 the K here. So finally, after calculator, 15 minus 320 multiply 3.6. What is, hold on. That is the minus value. Maybe Eden, did you calculate before? Oh, okay. So I'm sorry about that. That was for yeah, 3.2, right? Yeah. So, yeah, 3.2. I'm sorry about that. 3.2. 15 minus 3.2 million multiply 3.65 from what that calculator. So 3.2 multiply 3.6.
I got 3.5. I was gonna say, oh, well, you go. I was like, that's.
So 15 minus 11.2, approximately, 3 point, 2 something. Okay, both things. All right. And then the final question, what is the I sub E? The I sub E, I sub B plus the I sub C. Okay. That is for I sub E here. Okay. And that was I sub B. That was I sub C. Okay. So I sub E is equal to I sub B plus I sub C here. So now we have already calculated the I sub B, what? 32 microamp plus the I sub C, 3.2 milliamp. Okay. All right. Any questions? All right. So I'm gonna have to skip for not skip. Yeah, skip for the question 4, and then we're gonna have the last question 5, the question 5. Okay. All right, that is really the same circuit, because I think you might be the confusing, but I'm gonna have the writing for you here. So that was V sub CC. That was R sub C, 1 kilo ohm here. Okay, and that was V sub BB. That was R sub B. So that was B, the base. E is the emitter. C is the collector. That is the second approximation. And the beta is, the DC is the 200 here. And second approximation mean V sub BE 0.7 all the way right there. So V sub BE 0.7. Okay. So same question. What is the V sub R sub B? You know what I mean? So maybe R sub BE 100 the K ohm, and V sub BB the 2 volt, V sub C 10 volt here, and then R sub C the 1 kilo ohm here. Okay, so one more time, right there. Okay, so we're looking for I sub B, A sub C, and V sub CE, same thing. Okay, 5 I sub E, 6 P sub D. Okay. All right. Just I'm gonna keep going for that one. Okay. So question 1, what is the V sub R sub B? V sub R sub B, that's right there. The voltage drop, the passing through current, you know, that is the I sub B right there. Okay. So V sub R sub B times I sub B, or V sub BB minus V sub BE. Minus. Okay. So that was 2 volt minus 0.7 volt, 1.3 voltage. That is the answer. The first questions. It's right there. Okay. All right. Any question? All right. The second one, what is the I sub B? The I sub B is V sub R sub B divided the R sub B. Why? Because that is, you know, we're gonna using the Ohm's law, okay, in this circuit right there. So this is why. So V sub R sub B, we have already calculated from here, the question 1, and divided R sub B 100 the K ohm here, 1.3. Not 1.3. Okay, hold on. Just 1.3, 1.3 that divided. Right. So 13 micro amp. 13 micro amp. And then the question 3. What is the I sub C? Hollis, what is the I sub C? What is the formula? Yeah, right. The beta, not B, okay? The beta, the times the I sub B. The beta is from the questions, the 200. So the 200 multiply I sub B, we have already calculated right there. So 2.6 million, right? Okay. And then the question 4, what is the V sub CE? The V sub CE like this one here, V sub CE. V sub CC minus I sub C times R, maybe R sub C. V sub CC more 10 volt, and then the I sub C 2.6 milliamp multiply R sub C 1 kilo ohm here. Okay, so the 10 volt minus 2.6 volt. Why? The K multiply the milli, Spanish. So that was 7.4 voltage. So V sub CE, 7.4 voltage. Okay. Okay, the question 5. What is the question 5? What is the I sub E? The I sub E, I sub B plus I sub C. So the I sub E is equal to I sub B plus I sub C. I sub B, we have already calculated, and I sub C, we have already calculated. Okay. So the last questions, what is the P sub D? The P sub D, V sub CE multiply I sub C. V sub CE, 7.4 volt. Why? We have already calculated from the question 4 and multiply I sub C. We have already calculated from the question 3, 2.6 million. So that was calculating 2.6. 19.24 milliwatt right there, milliwatt. Okay. The piece of the collector, the power distribution. Okay. All right. Any question? Thank you. So maybe again,